Welcome to this concept check on implicit differentiation. Let's explore a few key true or false questions to test our understanding. First question. If an equation in x and y defines y equals f of x implicitly, are the graphs of the equation and f identical? Pause the video if you want to think for a moment. This statement is false. Consider the equation x equals y squared. This equation implicitly defines two separate functions, y equals square root x and y equals negative square root x. While the graph of the equation x equals y squared is a full horizontal parabola, the graph of y equals square root x only represents the upper half, and y equals negative square root x only represents the lower half. Because the individual functions only cover a portion of the original relation, the graphs are not identical. Next question. Is the function absolute value of x not defined implicitly by the equation x plus y multiplied by x minus y equals 0? This statement is also false. We can see why by simplifying the equation x plus y multiplied by x minus y equals 0. Multiplying the terms gives x squared minus y squared equals 0, which can be rewritten as y squared equals x squared. Taking the square root of both sides yields y equals plus or minus absolute value of x. Because the function y equals absolute value of x satisfies the original relation, it is indeed defined implicitly by the equation. Finally, if y is defined implicitly by x squared plus y squared equals 1, is the derivative dy to dx equal to negative x over y? This statement is true. We can verify this by applying implicit differentiation. Differentiating both sides of the equation with respect to x gives the derivative of x squared plus y squared equal to the derivative of 1. Using the chain rule for the y term, we obtain 2x plus 2y multiplied by dy over dx equals 0. Rearranging this equation to solve for the derivative yields dy over dx equals negative x over y.